All right, some more vocabulary, because, you know, I cannot stress how important it is to know the words that are coming out of my mouth. No, so adjacent angles are like your neighbor, okay? So here's a visual example of what an adjacent angle looks like. They have a common vertex. If I get my fancy pen out and I say that this is, like that's point B, this is the vertex. And then this is the common side. So when you think about adjacent angles, think about your next door neighbor. All right, here is an example of non-adjacent, right? There's some angle in here that it skips over, right? So they are not next door neighbors. That is not adjacent. Here, there is no common side. Boom. Are we okay if I go to the next slide? And I can't see you if you guys are out there raising your hand in this virtual world, because when I share my screen, I only see what's on the screen. Okay, then. All right, next vocabulary word is complementary angles. They are two angles whose measure have the sum of 90 degrees. That means they add up to the 90. So we know that 90-degree angles are called right angles. I always say it's all right to give a compliment, huh? Who doesn't want that happening? Here are my visual examples. These are adjacent complementary angles. They're right next to each other, and 40 or 50 plus 40 is 90. And then here I have two non-adjacent angles, but their sum is 90. 55 plus 35 is 90. So these are complementary angles as well. One of your homework assignments for tonight, I think it's number 6. You're looking for the numbers that are going to add up to 90 when you get to that problem. So complementary add up to 90. Two angles add up to 90. Are we okay if I go to the next slide? All right, next vocab word is supplementary. They are two angles whose measure have a sum of 180 degrees. Here I have two adjacent angles, right? Let's say one is 70 degrees and angle 2 is 110 degrees. They are supplementary because together they make 180. Well, I guess I'll wait till I get to that point. Never mind. Here is another example. They're like interior. We'll talk about this next chapter. This is called consecutive interior. But let's say this is 150 degrees. And this angle in here would be 30 degrees. They are also supplementary. Same as the consecutive angles of this parallelogram. Like if this one, I have it at 40 degrees here, then this angle is 140. All right, supplementary 180. That's what I want you to think about. Complementary 90. All right, next, vertical angles. They are two angles whose sides form two pairs of opposite rays. Vertical angles are congruent. That is a theorem. Again, it's not as important because we don't write proofs, thank goodness. But when I think about vertical angles, what I want you to think about is like looking in the mirror. Who is directly across the mirror here? So angle 1 and angle 4 are vertical angles, and they are congruent. So they have the same measure. If I just said, like, theoretically, let's say this is 100 degrees, and this is 100 degrees here. Oh my goodness, I'm having a hard time writing my zeros. They are congruent. They're directly across from each other. That is vertical angles. Also, 2 and 3 are vertical angles. I will say that they are 80 degrees here. Angle 3 is congruent to angle 2. Vertical angles directly across, they share that vertex. And they have the same size. All right, then I have one more vocab word. Oh, somebody's chatting. It's all right, Cassie. I will fix the attendance after I'm done the lesson, okay? So we'll just, and then this is being recorded if you want to go back and watch the beginning part. It's riveting. I'm telling you, you're going to be like, you better have a bag of popcorn. So exciting. Okay, here we go. Number 5, vocab word number 5, a linear pair. They are two adjacent angles, so they're right next to each other, whose non-common side forms opposite rays. Notice down here, these are non-common sides. They are opposite rays. We talked about that earlier. I always say, if you can start at one angle on the line and make a rainbow connecting the other angle and get back on that line, that is a linear pair, a pair of angles whose sum is 180 degrees. I guess in my little picture, I should just say that this is the non-common side. And then this would be the common side, because that's what adjacent angles have, right? They have one common side. And then if I slap some numbers in here just to make it even more concrete, like let's say the measure of angle 1 is 58 degrees. That means the measure of angle 2 is 122 degrees, because 58 plus 122 is 180. So a linear pair are supplementary, and vertical angles are congruent. Does anyone need more time to write this down?
I do.
No problem. Now, not all adjacent angles are going to be supplementary, so just make sure you're aware of that. It's just because this down here, it has to have the fact that it has to have those opposite rays in order to be a linear pair.
All right, I'm good.
Excellente. All right, let's look at some examples. All right, here I have a fancy drawing here. We're going to identify all of the linear pairs in this figure, and then we'll identify the vertical angles in this figure as well. All right, so remember, when you're thinking about a linear pair, you are looking for adjacent angles, meaning they're right next to each other, they're like neighbors, and they have opposite rays. So can anyone see a linear pair of angles here in this picture? I'll give you a hint, there's only two.
1 and 3.
Ooh, well, if we were talking about like a triple or whatever, like if I started at angle 1 and I went all the way over, I also have this angle too. So remember, a pair is just two angles. So I like that you were getting there, but what if you went the other direction? Like what if I started at angle 1 and I went around?
1 and 4. Yeah, I was just about to say that.
Yeah, perfect. Okay. So as far as linear pair, I guess I'll just write it above the word linear pair. So angle 1 and angle 4. All right, so that's one set. Is there another set here? Well, there is. I already told you there was. So can you see it?
Four and 5.
Excellent. Yes. All right, I start here. I make my little rainbow. I'm including two angles, 4 and 5. That's perfect. Angle 4 and angle 5. All right, that's it for linear pairs. Now for vertical angles. Remember, they share a vertex, they're directly across from one another, and they are the same size. So if you might be thinking, oh, 4 and 3 are vertical. Well, 4 is clearly an obtuse angle, and 3 is not. So that's not going to get us there. I'm looking for two congruent vertical angles.
1 and 5.
Yes, 1 and 5, right here and here. Perfect. Angle 1 and angle 5. Those are vertical angles. And then these guys are the linear pairs. The shorthand is terrible. I apologize. All right. Let's look at some more examples. Let's check it out. All right, number 2 says, given that angle 1 is a complement to angle 2, and the measure of angle 1 is 68 degrees, find the measure of angle 2. All right, first off, let's review. What does complement mean? What is it supposed to add up to be? Remember, I was like, it's all right, to give a compliment. Complementary angles have a sum of what?
90.
Yes. So I want you thinking about 90 degrees. That's a complement, okay? So I'm going to start with that 90. And I'm going to subtract out the measure of angle 1, and I'm going to find the measure of angle 2. So 90 minus 68 is equal to 22. So the measure of angle 2 is 22 degrees. All right, now let's look at the next example. Number 3, it says, given that angle 3 is a supplement to angle 4, and the measure of angle 4 is 56 degrees, find the measure of angle 3. What does this mean to be a supplementary angle?
(180 degrees).
That's right, it adds up to be 180. Right, so that's what we're going to start with. We know it was supposed to be 180 together, so we subtract out our one angle we have here. So 180 minus 56, oh, I got to cheat, is 124 degrees. So when I write my answer, the measure of angle 3 is 124 degrees, because 124 plus 56 is 180. All right, easy peasy, lemon squeezy. All right, and I only have 3 more examples left. I'm so excited. Oh, and I mean, I don't know if you guys, I'm sure your other teachers told you this, but they were really talking about this snow coming out tomorrow. So we might have a snow day. All right, let's look here. Number 4, we're going to find the value of x and then find the measure of each angle. Remember, a lot of us celebrate early and we're like, woo, we found x, boom, moving on. But we got to remember to plug it in here, okay? Because it does say, and find the measure of each angle. So first off, looking at these two angles, what are they? I mean, I see they're adjacent. But together, if I can draw a rainbow over both of these angles and get back to the line, what do we call that?
Supplementary.
Supplementary, because they're a linear pair. Yeah, so we need to know that because that helps us set up our equation. Like it's the difference between setting them equal to each other, setting them, adding them together, 90, adding them together, setting the 180. So supplementary means they add together and equal 180. So we just take these expressions, 4x plus 8, add x plus 2. And we know together those two angles equal 180 degrees. All right, now we use our math magic and solve this, right? I have like terms on the same side. This gives me 5x. I have like terms here. 10 equals 180. Subtract 10 from both sides, and I get 5x is equal to 170. Divide by 5, and I get x equals 34. All right, cool. Don't celebrate just yet. We have to plug it back in to the expressions on both sides. 4 times 34 plus 8. Oh, gonna have to bust out my fancy calculator. What do we get here with that? 4 times. We should get 144 degrees for this angle on that side. Now when I plug in here, it's gonna be a lot easier because I just take 34 degrees, add 2, and we get 36 degrees. You want to make sure that you're answering the question. All right, and we know 144 plus 36 degrees is 180, so hallelujah, we did it. All right, let's, we got 2 more examples here. All right, example 5 says angle LMN and angle PQR are complementary angles. Find the measure of the angles if the measure of LMN is in this expression, 4x minus 2, and the measure of angle PQR is equal to this expression, 9x plus 1. First off, I'm pretty sure we all know the complementary angles equal 90 degrees together. Okay, so we're going to take these expressions, add them together, and set it equal to 90. 4x minus 2 plus 9x plus 1, all of that equals 90. Combine like terms, 13x minus 1 equals 90. Add 1 and I get 13x equals 91. Right? What's 91 divided by 13?
Seven.
Thanks. Yeah. Oh, someone chatted. And I'm sorry. So the chat window is like hidden in the bottom of my toolbar. I don't know how to keep it up. So when somebody chats, I don't have to keep. Oh, excellent, Nate. You had it. You knew it. All right. Don't celebrate just yet. Yes, we have part of the answer, but we need to plug it in because we need to find the measures of the angles. So if we look at the measure of angle LMN, when I take 4 times 7 minus 2, well, 4 times 7 is 28, minus 2 gives me 26 degrees. And I'm sorry about my handwriting. It is what it is, right? All right, so now I need the measure of angle PQR. You can either at this point take 90 minus 26, or you can plug it into this expression, right? 9 times 7, that's 63, plus 1 gives me 64. And 26 plus 64 is in fact 90, so we are amazing. Okie dokie. Anybody need another second till I go to the next example? All right, let's take a look. Oh my gosh, this one's ugly. Why? Because it has X's and Y's in it. And you might be thinking, oh my gosh, systems of equations. Not yet, but do not forget about how to do systems of equations. I'll try to refresh your memory before we get there. So you might look at this and be like, oh, there's a linear pair, right? 4y minus 15 plus x plus 15 is 90. But then I have two variables and I don't like the looks of that. So I'm not going to do that. But I can see here that y plus 20 and 4y minus 15 make a linear pair, which makes them supplementary. So I can set up an equation with that, 4y minus 15. Not that you couldn't have done systems with this, by the way. So 4y minus 15 plus y plus 20, all of that is equal to 180 degrees. And we use our mathematics. Right, and I get down to 5y equals 175. I divide by 5 and I get what? Y is equal to something.
35.
Excellent. All right, and now we can kind of super celebrate because the equation, the thing just said find x and y. So we found y. Now it's time to find x. Notice I have the same thing on the other side. These two angles together make a linear pair, which makes them supplementary. So x plus 15 plus 3x plus 5, all of that equals 180. All right, find like terms, 4x, boop, boop, plus 20 equals 180. Subtract 20 and I get 4x equals 160. And we're so close to the finish line, this is amazing. What does x equal?
Forty.
40. Perfect. If we wanted to plug them back in, we could. I actually will just plug in to this expression here because 40 plus 15 is 55 degrees. And then I'm going to plug in my y down here. I just want to show you something because 35 plus 20 is 55 degrees. And notice how these were two vertical angles, right? So they're congruent. So I just wanted to show you that. That's pretty cool. And I am thinking about getting a sound box like Sam from iCarly. My son's been watching that, and I want one. I want some noisemakers. That'd be so fun. Because, you know, it just add a little excitement to math, you know what I mean? All right, here's your assignment for today. Number 6, page 38 to 40, number 3 to 44. You do not need a protractor for today's assignment, so you should be okay. Make sure you write this down. Does everyone have this written down? All right, cool.